This is vlog number 3, Firing and Reflection. We will be firing the cannon and going over some questions reflecting the design, science, and outcome of our cannon.
What is this? CO2 and water. Let's see what we have here. Ready? 3, 2. Yep. You've got an airtight problem.
Pros and cons of our design. The pros was it supported well and did not need to be held up by any of the team members, unlike some of the other cannons we saw. The cons was the pressure plate, because we kind of improvised that at the time, so we didn't really have that in the design. You know, we'll talk about that some more in the pressure plate and what we needed to do better, but those are the main pros and cons.
The launch angle we chose was 45 degrees, and was it the best choice?
Yes, it was.
Because of online testing done in the last video, we could use that 45 was the best angle. It would have worked good had our cannon design been successful though.
A distance shot. Our cannon did not successfully fire, so it traveled 0 feet.
So, difficulties in construction. It was hard to insert the pressure plate in. I think that was our main difficulty here when we, because we had done all the rest of the design and hadn't really taken into the fact of the osmotic pressure. So, as a result, when also it didn't work.
I like how we worked together and the time management we had to learn. Also, the design of our cannon was similar to that of an actual smoothbore cannon, so it might have worked well had we not had the problem of the back gate crap. All members of this team worked very hard and didn't stop trying, even though it required many hours of hard thinking.
Okay, so the other difficulty in construction, besides the fact that we had to insert the pressure plate and it wasn't exactly sealed, because we didn't really take that into account at first, was the fact that the opening that we made was not big enough for the match, so we had to rotor it out before firing, which wasn't exactly the best. So if we had to redo it, I would say that we would have definitely taken into account a pressure plate and at least 2 of them in 2 different positions on there to count for the osmotic pressure, and the fact that we would have a bigger hole for it in the back.
The equation used for the cannon firing was a combustion reaction, which is C2H6O, and that makes 2 CO2, 3 H2O.
Gay-Lussac is an Indian, so he lives in a TP, meaning temperature and pressure. When we fired the cannon, it was I'm gonna say lower temperature than normal, which does have an effect on the pressure, so I don't think it would have gone as far as it would have on like a regular normal sunny day, which he also said to us to take into account for. So if our pressure hadn't been already jacked up from the stupid pressure plate, then it would have been better. Pressure was already taken into account for, considering the fact pressure plate, which does relate to osmotic pressure, which we'll get to later. Volume, I'm going to take that into account as the air inside there and also the stuff that was put in there, the volume of that, which, how much was that again? Does someone remember?
Volume for what?
For the, what he put in there, the reaction.
Wasn't it like something milliliters?
I know it was ethanol, but
I think it was like 50 milliliters? 1 milliliter?
Okay, 1 milliliter. So that would be our volume there that was put in there. So that could, volume and pressure, that always affects that as well. That's Boyle's law. There's Charles' law. Charlie Brown is on the TV. That's temperature and volume. Volume we just talked about. It was the 1 milliliter of ethanol, and then temperature would have been the temperature outside at the time. So that's how that would relate into this. This would really just be a really big combined gas law equation if we wanted to do that out. I'm just kind of explaining how those things fit into it. I'm not going to really go into more depth than that unless we want that. Avogadro's law is the thing. with the thing, Avogadro's number. I remember that. Moles. Thank you. Moles. That really helped. Moles. So the moles, you know, ethanol he put in there, and also what we get out. How many moles of that was left, which we would have had, you know, CO2 and H2O. How many moles of that was in there?
Osmotic pressure or colligative property. The purpose of the pressure plate was to increase osmotic pressure. It will force the air through the holes and make the reaction more pressurized and will launch the cannon.
So after we reflected on everything we did for this project, we made a table for what we liked and what we would change. So some things we liked about our cannon was that the cannon had a very similar design to an actual smoothbore cannon, which is one of the most common cannons people probably think about when they think cannon. We also were really good with conserving our materials, so that when we found out that having a pressure plate would be helpful to our cannon design, we had a lot of leftover materials and were able to construct one. Even though it didn't work properly, we were still able to construct one, so we were good at conserving materials. And also we had a pretty good design on our cannon with some marker swirls, made it look pretty attractive.
We would all have probably changed the pressure plate with the holes in it, because even though we were advised to use it, it caused more trouble. We could have created a tighter hole to allow access to the very bottom of the cannon, and finally we could have changed the compartment for the pressure buildup. We didn't take into account that it would be too small. We should have made a bigger space for the pressure buildup. I think this is a screenshot.